Hello everyone, this is Mr. 13 Things, and we're here to do a kind of a test run using a program called Memrise, adding this as a multimedia level. And what we're going to be targeting here is learning the tangents of key angles in the first quadrant, okay? In first quadrant. And what those key angles are every pi over 12 radians, or every 15 degrees. And you're going to notice how different that is than pretty much most any other thing you see out on the web where they ignore 15 degrees. This is prefaced onto something where we're just going to learn literally the first 45 degrees of a circle and its key values. But there is a value in learning the tangents of every 15-degree increment, or pi over 12 increments, from 0 to 90 or 0 to pi over 2. And that value comes out of the fact that a typical line equation can also be written as y equals the tangent of the angle times x plus the slope-intercept. So that's why, if nothing else, we're going to memorize or learn to memorize each of these values of the tangent. So let's first talk about the definition of the tangent. The tangent, if you remember, is often learned as the opposite over the hypotenuse. And so if you have basically a right triangle, if this is A and this is B, and this is an angle B here, the tangent of B equals the length of B over the length of A, opposite over adjacent. However, there's probably a better, more formal and more intuitive definition, and I'm going to show that to you here. I will do it here at first for this angle on the unit circle here. This unit circle has a radius equal to 1, an area equal to pi, and a total angle equal to 2 pi. That's not an eye, that's a total angle. So you can figure that out later, but the radius of the unit circle is 1, and we're going to look at that dot there, and we're going to draw, extend that line out here, we're going to draw a tangent line, which is a line that touches the circle at one spot there, which means it has 90 degrees there. And if in fact the length of that line is actually the tangent of that angle theta here, right? So it's oddly obvious but never taught that in fact the length of that tangent line is also the opposite over the hypotenuse of this triangle, which is this is the sine and this is the cosine. So the concept of what is a tangent is actually two things on this circle. It's either the length of that line, or in fact it's also the length of, I'll do this in a dashed line coming up, it's a length of this line. So these are both the same line lengths. And so that's a little backstory for you, and what I'm going to do now is just show you the memorization technique, if you would, and it starts with a knowledge factor of, I'll do these for us in actually degrees. So I'll just do 0 degrees, 15 degrees, 30 degrees, 45, I'm going to go all the way up to 60, 75, and 90, and these are degrees. First off, from memory, it's a great idea just to learn that the tangent of 45 degrees is 1. Okay, and you can think about that length here. If this is 1, then this is 1. So the tangent of 45 is 1. The tangent of 0 is this line, kind of this laser goes down. The tangent of 0 is 0. And the tangent of 90 becomes essentially the length of a line that never intersects, so we're going to say it's undefined. Now you've got a visual clue in terms of a sense. Now comes the memory on the first two. Getting involved with the square root of 3, which comes up all the time in tangents, you'll see it. The tangent of 60 is going to be a longer line, and it's the square root of 3. The tangent of 30 is a shorter line, and the square root of 3 is involved, which is 1 over the square root of 3, but 1 over the square root of 3 is the square root of 3 over 3. So you have 60 as the square root of 3 and 30 as the square root of 3 over 3. Now becomes the most interesting one. It's not the easiest and most obvious one, but it's a simple pattern. it is 2 minus the square root of 3 for 15 degrees, and later on you'll see why, but what it is for 75 is 2 plus the square root of 3. So your memorization for angles going from 0, 15, 30, 45, 60, 75, and 90 is really you're going at the extremes, 0, 1, and 90. 0, 1, and undefined or infinite for the 45s. A little bit more or less based on a 1 hour increment of spin of the Earth, or 15 degrees, is the square root of 3, because that line is going to be longer. The tangent of 60 is longer than the tangent of 30. So it's the square root of 3 and 1 over the square root of 3, but very quickly you understand that 1 over the square root of 3 is the square root of 3 over 3 when you multiply both sides, or multiply the top and the bottom by the square root of 3. So you have 0, 1 undefined, you have the square root of 3 and 1 over the square root of 3. And then for this one you just have, basically this is the root memorization, if you really want to think of it that way. At 15 degrees it's going to be less still, and that becomes 2 minus the square root of 3. At 75 degrees it's 2 plus the square root of 3, and these in the end have an approximation which is about equal to the angle, which in this case is pi over 12, and this one is about 12 over pi. Not perfectly, so these are approximations. And learning how to get an approximation back to the start is an important thing, so I'm going to lay them out now here in another table. We're going to say degrees, radians, and the tangent value. And I'm going to kind of make a bad table here. 0, 15, 30, 45, 60, 75, and 90. And later on we're going to realize we really only need to learn the first 4, because the rest of these are just inverses. But radians, this is 1/12 of the way around the circle, which is 2 pi around, so this is pi over 12. This is 0 radians. This is pi over 12. This is pi over 6, twice times this. This is 3 times that, so that's pi over 4. This is twice that, which is pi over 3, and this one is basically 5/12 of pi, and this is just pi over 2. The values, again, as we fill in this chart, the length of that line is 0 when the angle is 0, the length of that line is 1 when the angle is 45, and the length of that line is undefined. I'm going to put infinite here because that's essentially what it is. At 60, it's the square root of 3. At 30, it's 1 over that, or 1 over the square root of 3. You know that this length of line has to be less than 1. At 15 is where it gets a little odd, but 2 and 3 are involved, and this is 2 minus the square root of 3. And at 75, it is 2 plus the square root of 3. Later on, you're going to see in the end, you really only need to memorize or understand or commit to memory the first 45 degrees of or the first half of the first quadrant. However, for tangents, it's kind of important to know these because you can start to recognize and visualize what a line looks like when you see it equals y equals mx plus b, because m is the tangent of the angle of the line. And finally, for approximation, remember that for a small angle, so 2 minus the square root of 3 is about, it's an approximation, it's about pi over 12, because the tangent or the sine of a small angle is the small angle. So we start by learning the tangents because it gives us a redundancy when we learn other things, and this will be the only thing that I would suggest when you really want to understand the unit circle. This is the only thing you learn from 0 to 90. Everything else you learn first from 0 to 45, and then think about reflective and symmetry patterns. So, reviewing, 0, tangent of 0 is 0, tangent of pi over 4 is 1, tangent of 90 is infinity or undefined. If you're a little bit bigger by 1 hour's turn or 15 degrees, you're at the square root of 3 for the tangent. If you're a little bit less, you're 1 over the square root of 3, which is the square root of 3 over 3. For math teachers. At 15 degrees, it's 2 minus the square root of 3. At 75, it's 2 plus the square root of 3. You'll see later why that works. That's our memory. Try to go from there. Thanks.